Hi Daniel, I hope that you are well. I've received your first question and I thought I would give this a video reply because this is quite a tricky one, I guess. So let's just see if we can get this done and dusted on a video reply for you. So with regards to question 21, essentially what we're looking for is the internal rate of return. Now it's quite interesting that you say that you understand the concept and essentially you're just looking for zero. I would probably disagree with that, Daniel. The IRR, why it does look for zero, it's not really looking for zero arbitrarily. It's looking for the internal rate of return, which is really the break-even point. Okay, so that's the concept of the internal rate of return. It's the break-even point. Okay, so this is where typically we would take X amount of money, invest it, and we will get a rate of return. Now, if we have borrowed money to invest, okay, say 5%, we need to know what our break-even point is, i.e. 5% before we start earning any money over and above the return. So the internal rate of return at this level is very simply the break-even point. So let's have a look at this question in a bit more detail. You said that you didn't really understand what was going on here with regards to the actual answer for the solution. So what we need to know is first and foremost what the actual formula is for the internal rate of return. So we have the internal rate of return is the sum, quite an appalling sum there, it's the sum of the cash flows in each of the years divided by 1 plus R. Okay, now we're quite fortunate that we will always be given, in this particular unit, we're always going to be given the answers. Otherwise, what we need to do in later levels, particularly the CFA, we need to have a look at iteration. And this is where we will use some generic formulas to get an approximation of a formula or a rate of return to be using here. Okay. However, we are already given those rates of return in the actual exam, so we don't need to do any iteration. We can just plug in each of these actual figures, okay, into this formula, which is, I've started it, so it's the cash flow 1 over 1 plus R in the first year, then exactly the same for the second year. You see what we're doing here, we've gone from year 1 to year 2, so we're squaring. And then we do that for as many times as the question decides, up to the final year, which is the cash flow N divided by 1 plus R to the nth year. Okay, so if we try and approximate this internal rate of return now for this question, all that we need to do is, as stated, just try each of these figures. So 14.96, 16.05. Now all we're going to do, we're going to use the correct answer in this particular scenario. So we're going to have a look at the cash flow in year 1, which was 13 pence. Okay, so we're going to do 13 divided by 1 plus, well, we know that this is the right answer, so let's convert this into decimals. 1496, okay, 0.1496, okay, so that's cash flow 1, and we don't need, it doesn't affect the answer, but just so we know we're following the formula, we'll just do a little one there as well. Okay, the next cash flow is 16, okay, and so what we do here is 16, then 1 plus 0.1496. It's the second year, so what we need to do is we need to square that. Okay. Now also what happens at the end of the second year, he sells the shares for 125p. Okay. So what we can do is we can exactly do it as the formula suggests. 1.01496 squared Well, actually, what we could do, we could add the 16 and the 125 together. Why can we do that? It's because, well, they're both materialising at the end of the second year. So just to make things a little bit simpler, what we will do is we'll just do, we'll lump those two together. So 16 plus 125 equals 141. Okay, in the second year. So 1.01496 squared. Okay, so let's have a look now. So we are looking for the correct answer, obviously, which is if we do 13 divided by 1.1496, and that is just simply adding everything up into that together. We get 13.1.1496, and that equals 11.85 to 2 decimal places. Okay, now what we need to do is we need to add up this little bit here. So we have 1.1496, so 1.1496, and then we square that, and that gives us 1.32 to 2 decimal places, and we'll also have in 141 on the numerator. Okay, so do you understand where that's coming from? The 1.32 just relates to 1.32 relates to 1 plus 0.1496, which we're squaring. Okay, and on the top bit relates to 1.41. So if we do 1.41 divided by 1.32, you should get on your calculator, that is equal to 106.82, really, to 2 decimal places. Guess what? If we start adding these two together, 11.85 plus 106.82, 106.82 plus 1.85, we get 118.67. And remember, I said everything is an approximation, okay? And so a return of 14.96% per annum will give us 118.67, and that's very roughly correct. And you will see that if we start plugging in 16.05, well, we'll actually start getting a smaller figure than 118, maybe 116.5. We plug in 13.48, we will start getting over and above 118, maybe 119, and 12.77 going to give us a bigger number, maybe 122, something like that. So our best bet here is to use 14.96. Okay, so I hopefully have covered that off in enough detail for you there. It's just really trying to understand exactly what the answer and the formulas are saying around about here, which they're not particularly clear if you look at them, but the reasoning is, okay? So you just need to plug in the figures from this formula that you need to memorize from here, from the actual answers. And that way you don't have to get into more complicated formula of iteration. Okay, I hope that helps, Daniel, and best of luck. Thank you.